All right, this video is going to go over 16.1c, which is how to solve logs, specifically the ones where there's only the log word on one side of the equation. So let's go ahead and get started. Look at this first one. You definitely need to be able to evaluate a log. So when I say evaluate a log, we get log base 3 of 27. When you evaluate a log, basically you imagine it equals x and you snail it, so it's like 3 to what power makes 27. Now you can probably just look at this and be like, okay, well that has to be cubed, right, to the third power. Or you can break it down to get the same base on an exponential problem, because if you do that, then you can set the exponent equal to the exponent and you can get x equals 3. So when you evaluate it, you'd be like, okay, well this whole thing right here is just 3. So that's what I'm saying when I say the word evaluate. All right, so that first part's 3. And then you evaluate log base 4 of 16. This is like 4 to what power makes 16? Well, that would have to be the second power. So this part's 2. So you have 3 plus 2 equals x. So now it's just x equals 5. And that is a very basic solving log problem. All right, let's look at number 2. When you see a number in front of the log, you kind of want to ignore it at first and just evaluate this part. So if you evaluate this part, it's like 5 to what power makes 125? Well, that has to be the third power. Now you can be like, okay, now I had a 2 in front that was multiplying, right? So 2 times. So this is this whole section right here, the green and pink. Now you still have the log base 6 of 1 over 36. So this part's a little tricky. When you snail this one, I'm referring to this right here, it's like 6 to what power makes 1 over 36. So call 36 6 squared. And then to bring it up to the top, you just make it negative. So it'd be 6 to the negative 2. So this has a value of negative 2. All right, so we had a plus in the middle, it equaled 12x. All right, so now just go solve it. So you have 6 minus 2 equals 12x. 4 equals 12x. Divide by 12, x is 1/3. Okay, moving right along. Now, if you see a log with the letter x in it, you can't evaluate it. So you kind of just leave it alone for a second. You can evaluate this one though. This one would be like 11 to what power makes 121? Well, that's squared, 11 squared. So this one's 2. So really what you have is log base 2 of 4x minus 2 equals 2. All right, now, if you have this x in your log here, you're going to want to try to isolate this log on one side of the equation. So what I mean by that is move this minus 2. Because you want to try to get it to log of something equals number. Because if you can get it here, well, now you can snail it like this. So you have 2 to the 4th equals 4x. Well, 2 to the 4th is 16. And now you can just divide by 4. So you get x equals 4. So again, if you have an x in your log, you can't evaluate it. So you evaluate what you can. We got 2. And then you try to isolate that log with the x in it. Because if you can isolate it, then you can snail it and take it to exponential. All right, so like look at this next one. I'm not going to be evaluating this log base 2x plus 5. I can't. So I'm going to evaluate this one though. This is like 2 to what power makes 32? Well, 32 is 2 to the 5th. So this one has a value of 5. So you really have like 5 plus log base 2 of x plus 5 equals 8. And so now, like I just said, you're going to want to isolate this log. You want to get it by itself. So I would minus 5 here. So you get log base 2 of x plus 5 by itself equals 3. Now you can snail and get 2 cubed equals x plus 5. Well, 2 cubed is 8. Subtract 5, x equals 3. All right, this next one, you're going to evaluate the top and bottom separate, but the top has an x in it right here. So I can't do that one. I kind of just leave it alone for a second. But this right here, this is like 6 to what power makes 36? Well, that has to be 2. So really what you have is you have that log base 8 of 4x over 2 equals 1. All right. Now, when you get here, you have to cancel that 2 on the bottom. So you're going to times by 2 on both sides of the equation. So now what you have is log base 8 of 4x equals 2. Now that it's log equal number, you can snail it and get 8 squared equals 4x. Well, 8 squared is 64. Divide by 4, x equals 16. Okay, this next one, we already have log equals number. So this log had an x in it, so I couldn't evaluate it right from the start. But since it's already isolated here, I can go ahead and just snail it. So I get 6 cubed equals 108 times x. Well, 6 cubed is 108. So when you divide, you just get x equals 1. Like that. All right. Number 7. Isolate that log so you get minus 15 right from the start. Because I want to get this by itself. So you end up with log base 4 of 5x equals negative 13. Now, this is going to be a really weird one. You're going to snail it, and so it's like 4 to the negative 13 equals 5x. I think there's got to be a typo or something on this problem. Or, okay, no, this is what they probably wanted. They probably wanted it to have parentheses here. So we'll treat it like that. Otherwise, it would have been really weird. So it's ready to snail right from the start. So you get 4 squared equals 5x plus 15. Well, 4 squared is 16. Minus 15. 1 equals 5x. Divide by 5. We're going to go with x equals 1/5. Okay, now these last two. You can kind of picture this one as like parentheses around this. And so it's ready to snail right from the start. So you get 3 cubed equals 24x over 8. All right, well, 3 cubed is 27. Like this. And so there's 2 ways you could handle this. You could either times by 8 right now and then divide by 24, or you can reduce this 24 and 8 to be 3 over 1. So it's really like you have 27 equals 3x. That's much easier. And so now it's just divide by 3 and you get x equals 9. That's how I would have done it. If you did it the other way, though, if you did it like 27 equals 24x over 8, you could have times by 8. These would have canceled. And you get 216 equals 24x, and then you could have divided by 24. Either way, you'll end up with x equals 9. So, all right, and then this last one. On this one, there's no base, right? There's the missing number here. Well, when that happens, it's a 10. And so you're ready to snail. Imagine this is in parentheses again. So you're ready to snail. And so you got 10 squared equals x squared minus 15x. 10 squared is 100. All right, now this is a quadratic that you have to solve. So you're going to want to make it equal 0, but you want to go towards the x squared. So you're going to minus 100. Be careful with your like terms. So what you have is you have x squared minus 15x minus 100, and it equals 0. You do this so that you can try to factor this, right? So you can factor it as x plus 5, x minus 20. And so the reason you want to factor this is because you can set each factor equal to 0. And get both answers. All right, so that is evaluating log, specifically when the word log is only on one side of the equation. They're not that bad. Generally, though, you're going to want to get log by itself on one side of the equation. That way you can snail it. So hope this video helped.